so here is a review on the basics of acids and bases. For the first question, we need to know the definition of, well, for all the questions, we need to know the definition of a Bronsted-Lowry acid and base. So an acid is the H plus donor, and the base is the H plus acceptor. The acid does not function alone. To have one, you need to have the other for a Bronsted-Lowry acid and base. So taking this definition, we look at our answer choices. So an acid is a proton donor, acid is a proton acceptor, C forms stable hydrogen bonds, breaks stable hydrogen bonds, or corrodes metals. So although an acid does corrode metals, and it can break weak hydrogen bonds, this is not the definition of Bronsted-Lowry acids. So we get rid of these, and boom, an H plus donor is an acid, and that's right here. Okay, number 2, it's asking us the same thing, but what is a Bronsted-Lowry base? Well, it's an H plus acceptor. So B is our answer, written right there. That's an acid. These are not. Okay. 3, the following reaction in an aqueous solution, the acid reactant is blank, and its conjugate base product is blank. So finding the acid, we need to find the reactant that is losing or donating the H. So we see that acetic acid is a product with a negative charge. Well, it's ion, it's a conjugate base, and now it can act as a base because it is ready to accept an H plus, which is what a base does. Bases are H plus acceptors. So this would be our answer because we see that it loses an H plus, and then its conjugate base is ready to accept one. So A is our answer. In the following reaction, in an aqueous solution, the acid reactant is blank and the conjugate base product is blank. So the same thing, different reaction. So let's find the one that is losing the proton. So this one is actually gaining a proton, so it's not going to be our answer. But if we see this one, HSO4 negative, it goes to SO4 2 negative. So this is losing an H plus because it does not appear on the other side. And its conjugate base is ready to act as a base because it can now accept, since it has no H plus, it can now accept one. So that would make our answer D. 5, which of the following is the conjugate acid of the hydrogen phosphate ion HPO4 2 negative? So the conjugate acid or base needs to differ by just one H plus. It can't differ by more, or it's no longer the conjugate. So if we want a conjugate acid, we want one with just one more H. So we want to see H2PO4 negative with one higher charge because we've gained that proton. And that way this can then act as an acid because it has another proton that it's able to give away. So our answer choices, that's incorrect, incorrect. This B is our answer because it's exactly what we wanted. This one, incorrect. Hope this kind of jogged your memory.